Hello, Precalculus student. This video is for Chapter 1.2, Part 2. We will look at piecewise function and also how to find domain and range of an application function. So piecewise function, what is piecewise function? Piecewise function is a function like f of x, but instead of one formula, it would have three formula. Why would we have three formula? We say for a function it's supposed to have one output, so why do we have three output? No. What happened is you only pick one formula for your output. Because at the end of each formula, they tells you the domain that this formula serves. That means if x is in this domain, then you use this formula. If x is in the second domain, you use this. And these domains should not overlap. So at any one point in time, your x should belong to one of these intervals. And then you will pick your formula to find the output. Okay, so let's look at this. So this is very useful when you look at working on applications. So that's why we talk about this before we work on application. So for example, a function f of x equal to, you will see a big bracket like this, and then there's two formula list vertically. So the first formula is f of x is y, the output is calculated by x plus 1. And then if you look further on, it would say if x is less than -2. That means when x is smaller than -2, then you use this formula. And then the second is -2x minus 3 if x is greater than or equal to -2. So you can see that they don't overlap. If it is exactly -2, you would use the second one, right? Because x is greater than or equal to -2. At times, there may be cases where there's some value that is not defined, so it would just be undefined. But most of the time, all x values are defined. So find f of -3. So when we do that, we need to look at this x input first. X is -3. So we'll check the domain on where x falls into. Is negative falls into x less than -2? Yes, -3 is less than -2, so it is in this domain, so we'll use the first formula. So we would use x plus 1, right? X is -3, so -3 plus 1 equal to -2. So that's our answer. What about f of -2? Well, actually, -2 is in the boundary, right? But when x is equal to -2, it is clearly in the second domain, so we would use the second one. So we would use -2x minus 3. Plug in x equal to -2 to it. Minus 3, so become 4 minus 3 equal to 1. So that's our answer. Find f of -1. -1 is -1 in the first interval or the second interval. Look carefully. -2 is our borderline. The first one is when it is less than -2, so that would be using x plus 1. And then this is when it is greater than -2, so it's -2x plus 3. Sometimes I draw a number line so I can see. Where is -1? Oh, -1 is actually here, right? Oh no, -1 is actually bigger than -2, is actually right here. So I say I use -2x plus 3. -1 is actually bigger than -2, right? So it's -2 times -1 plus 3. So it's 2 plus 3 equal to 5. What about f of 0? So look at the number line. 0 is also on this side, right? So 0 is here. So it's covered by -2x plus minus. Oh no, it is not plus 3. It's minus 3. I make a mistake here. This is minus 3. So it's 2 minus 3. 2 minus 3 should be -1. F of 0, again, I use -2x minus 3. So -2 times 0 minus 3. So it's 0 minus 3 is -3. This is -1. Yeah. So if you're confused, I think it's the good idea is to draw a number line and then you can tell, okay, at which interval is which. The second set of question would be, they give you a function has a piecewise function has two formula, and then we want to sketch it. So not defining, but sketch it. Now both of these x plus 1, negative 2, x plus minus 3, these are linear functions, right? They're line. So we have mx plus b. So we have the y-intercept and the slope. So it's very easy to do. So first of all, we would say, okay, so when x is negative 2, less than that, I use this, right? And this side is x plus 1. And when x is greater than negative 2 on this side, I use negative 2x minus 3. So first of all, I will find out at the boundary, what is x plus 1? So you will say, Miss Chen, and when it is at negative 2, we should use this. But I want to know when it is really, really, really close to negative 2. So I'll try for x plus 1. So when x is negative 2, although I should not use it, I want to know the open circle, what is it, right? So y would be negative 2 plus 1 equal to negative 1. So I would have a negative 2 and negative 1 here. So I have an open circle for this. And then I would just do rise over run. So this is, what's the slope? The slope of this is 1, right? 1 over 1. So I would do, so I cannot do rise and run on this side. So I would down and run on this side. So down, run, run left. So like that. Or you can just do 2 more points. So the graph should be like this. And what about the other one? Negative 2x minus 3. When x is equal to negative 2, what do I have? Negative 2 times negative 2 was 4. 4 minus 3 is 1. So for this side, the solid dot is 1, right? And then the slope is what? Negative 2 over 1. So it's down to 1, 1. So like that. Down to 1, 1, right? So like this. So that's how you graph it. So the third example is sketching, but it's not line anymore. And also we have 3 sections. One is when x is less than negative 2. So I dotted a negative 2 here. And then the other one is from negative 2 to 2. And then the other one is from x is greater than 2. So this is absolute x. This is square root x. And this is 3. I think the easiest one is 3. So because it's just I remember the function, the toolkit function. So it's like that. And then does it include negative 2? Yes. So we do a solid dot. And then from negative 2 to 2, we have square root x. But square root x is not defined when it is negative. So it's defined like this, right? So we would just go like this, right? So open circle, well, solid circle, but this is open circle. And then for x is greater than 2, then it is a V shape, right? So V just go 1, 1, 2, 2, 3, 3, 4, 4, right? So like that. So that is the graph of this function. So basically you sketch it by breaking them down. The last part is find domain of a function in application. So when you are looking at a function, an abstract function, you use the part 1 guideline that we talks about. Oh, if it's a rational function, its denominator cannot be 0. If it's a radical even, then the inside must be greater than 0. But if it's an application, so there are more restrictions. Sometimes because it's an application, sometimes the number has to be positive. And sometimes they tell you what is the maximum number, just like this one. Write the surface area A of a cube as a function of the side length x. So this is the first part. A, which is the surface area of a cube. Side length is x. Because it's a cube, all the side lengths are the same, right? Length, width, and height are the same. So surface area is 6 times x and x times x. Each side is x squared, right? And then I have 6 sides. So this is the surface area of the side length. of the of a cube. Now, if the maximum area is 800 cm, what is the domain of the function? So x can be, any number. So if you just look at it in a nutshell, this is a quadratic function. It could be any number, but because there is a restriction of maximum surface area is 800, so we will say, well, let's say the maximum A is equal to 800. So 800, what is the maximum X? It is uh, um, less than 800 is 6x squared is less than or equal to, let's say, we will say 6x squared is less than or equal to 800. And because x is positive, so x squared is also positive, right? So there's two restrictions. One is 6x squared is positive. Can it be 0? No, because it's real life, right? X must be, because x is positive. So 6x squared has to be positive. So let's solve this. So x squared would be less than equal to 800 divided by 6 is what? 400 over 3, right? And then x, if I do square root, would be less than equal to 200. No. Square root of 400 over 3, right? So that is about, what is 400 over 3 square root? Over 3, so that would be 11.5. 11.5. So what is the range of x that's available? X could be from 0 to 11.5, right? So we would say, so the domain is from 0 to 11.5. Like that, yeah. So that is the domain and range of a function. 1.2.